In today's video, we're going to talk about negative and zero exponents and their rules in order to evaluate with them. So first rule we're going to talk about is zero exponents. Any base raised to the zero power is simplified to zero. Be sure that only the base attached to the zero exponent is simplified. So for example, number 1, 10 to the zero power, that's just going to be 1. All right, this next one, notice that the only base that's attached to the 0 is the x. The 5 isn't really attached to the 0. So the exponent can only see what's right next to it. So this is going to be 5 times x to the 0 is 1, so that's going to simplify just to 1. Or sorry, just to 5. Same thing here. The 0 exponent only sees the y, which is right next door to it. So the x is going to stay the same. Y to the 0 is 1, so x times 1 is just x. Okay, the next one again, 0 right here, it only sees the b right next to it, so the 3a is going to stay. B to the 0 is 1, so my final answer here would be 3a. This last one is a little bit different because there are parentheses around 3a and b, so the base for this 0 becomes the whole expression, so it actually sees everything inside there. So think, for example, that the parentheses are kind of like windows, and the 0 exponent is going to look in the window and see 3a and b, so this one right here would simplify to 1. Okay, and at the top we have a summary of that rule. It says a to the 0 power is equal to 1. Okay, negative exponents. A negative exponent moves a base as part of a fraction. To simplify, we have to make sure the problem is written as a fraction. To make an integer a fraction, we put a 1 in the denominator. Move the power to make the exponent positive. So problems with exponents are not simplified until such time as all exponents are positive. If the base with a negative exponent is in the numerator, move it to the denominator. If the base with a negative exponent is in the denominator, we flip it up or move it up to the numerator. All right, so for example, I have 2 to the negative 4th. So I would move the 2 to the 4th down to the denominator. So this is going to become 1 over 2 to the 4th power. In this example, the 3 to the negative 2 is in the denominator, so it's going to move up to the top, and this will just become 3 to the 2nd power. Okay. In this example, the 4 to the negative 2 needs to go down to the denominator. When we move it, we leave a 1 in the numerator, and I have 4 to the 2nd times 5. If I would like to simplify that all the way out, that would be 1 over 16 times 5, and 16 times 5 gives us 80. So this simplified out would be 1 over 80. This one simplified all the way out would be 1 over 8, and this one would be 9. 4x to the negative 2. This exponent only sees the x, it does not see the 4. So the 4 will stay in the numerator, and the x to the 2nd will become a positive exponent, and it'll be down in the denominator. Okay, similarly, this negative 2 only sees the c, so the 3a to the 5th will stay where it is, and the c to the 2nd will go down to the denominator. Last example, we have a couple of negative exponents. In fact, we have 3. Everything that's negative in the numerator is going to go to the denominator, and everything that's negative in the denominator is going to move to the numerator. So this b to the negative 5, that's going to move down. The z to the negative 3 is going to move down, and the y to the negative 2 is going to move up. So if we do a little bit of rearranging here, the x to the 2nd stays where it is, the y to the 2nd comes up, and the a to the 4th stays where it is, the b to the 5th goes down below, and the z to the 3rd goes down below. Okay, we have 2 additional examples that combine both of these rules together. So I like to simplify those in 2 separate steps. The first one I look for are the 0 exponents, and then the second one I look for are anything negative. So right here I have a y to the 0 power. So that's going to be a 1. That gives me negative x times 1 times z to the negative fourth, which I know is negative x z to the negative fourth. And then this negative exponent needs to go in the denominator, so I'm going to be left with a negative x, and then z to the positive fourth. Okay, first thing I look for again are the zero exponents, so this is going to be 4m to the 0 is 1, p to the fourth over q to the second, sorry, negative second. All right, so that's going to be 4p to the fourth over q to the negative 2. And I have a negative exponent in the denominator, so that means that's going to have to flip up to the numerator. So that's going to give me 4p to the fourth, q to the second. And that would be left with a 1 in the denominator, so I don't need to write over 1 because it's just the same thing.